Hey everybody, video 5. This is going to talk about names and properties of the groups extensively. So after today's video, I can identify by name the different groups or families of an element in the periodic table. It's going to be a long video. We got a lot of them to do. All right, notice that picture is highlighted group 1. They all have one valence electron. They have luster, conduct electricity, they're ductile, and they're malleable. Quick review. All right, one valence electron. Okay. These are, first of all, the alkali metals. It says in the picture. You might want to write that somewhere. Alkali metals. One valence electron in group 1. Luster means shiny. Conduct electricity, you know what that means. Allows electrons to pass through. Ductile means to draw into wire. Malleable means to pound flat. Okay. These are the 4 properties of metals. So the alkali metals have physical properties of metals. I'm going to make you write those a lot in this video because later you're going to be asked, what are the properties of metals? Those are the properties of metals, those 4 things: luster, conduct electricity, ductile, and malleable. We need to know those 4. So when we go over them in group 2, and we go over them in transition metals, I'm not going to go into depth about what they all mean. I just did. Chemical properties, ready? They lose their 1 electron to become +1 ions. They are extremely boom in water. There's this, right? Put sodium metal into water and it explodes. Okay. They are extremely reactive, which means they are never found alone in nature. They react violently with water, specifically group 1. Never found alone in nature. They're so reactive that they have generally reacted with some element and form a compound. So we wouldn't find them in nature. Those are questions you're going to have to answer on Castle. Okay. You're going to be able to decode that. Oh, here's another good one. Look at that chunk of sodium. Watch, ready? Boom. Another one. Wait. Boom. Yeah. Come on, gonna go. That's fun. I want a chunk of sodium like that to play with. When do I get to play with sodium like that? That would be fun. All right, notes. They contain the most reactive metal, which is francium, which is in the lower left-hand corner. Did I do that right for you? The lower left-hand corner is francium. Reacts so fast we have trouble proving it has metallic properties. Most people, I don't know that anybody actually has francium as a sample. Generally, you have it into something that radioactively decays into francium, and they have a sample of that, and that they claim that there must be some atoms of francium in there because it's something that the metal that's in there is radioactively decaying into francium, so it must be there somewhere. And then it's got to be sealed so it doesn't react with everything else. But they can't actually isolate it and play with it because it reacts just with the water that's in the air. And you can't have a completely arid system. So just how it is. But francium, most reactive metal. Remember that coming up later. Okay, moving on. Alkali earth. Physical properties. 2 valence electrons now. Group 2, 2 words, 2 valence electrons. It's called alkaline earth metals, or alkali. Alkaline actually mean the same thing. It means basic. Okay. Alkali earth metals, 2 words. Alkali earth, group 2, 2 valence electrons, 2 words. Getting the hint. All the other metallic properties, they're there. I'm not going over them again. I'm not even reading them for you. Moving on, chemical properties. They lose their 2 valence electrons to become +2 ions. They are very reactive and very rarely found alone in nature. I believe that is magnesium burning. We've done this before in class, in one class anyways. We did this. Somebody asked me about magnesium, so we burned it. Okay, very reactive, rarely found alone in nature because it reacts and combines with something else. Okay, notes, remember, 2 words in the name for group 2, 2 valence electrons, two words, group 2. That's how we put that together, remember. Okay. Moving on, this lower block, including those lower pieces. We'll get into the lower pieces specifically in a little bit, but these are what we call the transition metals. Their valence electrons vary, but they have all metallic properties. The thing is they're transitioning, and we're good with that word now when we come to gender, right? They're transitioning from metal to non-metal, and they're in this lower, what we call the D block. And the picture is actually missing one highlighted piece because those 3 that are missing are transition metals, by the way. the they're transitioning from metal to non-metal, and if you look, their valence electrons vary. It's not specific because we didn't really get into what's called the d orbital when we filled s and p orbitals, and things get kind of crazy wackadoodle there because the filling order really changes, and we don't get into that in this course. So the predictability of transition metals goes way down. So the chemical properties are, number one, it forms colored ions in solution. So copper forms blue. That might have been the fun one that you played with in the flame test. I had that one blue solution, formed a pretty green color. Okay, they form colored ions in solution. That's the piece you need to know about transition metals. They tend to be very unpredictable. They will all lose electrons or gain them depending on other metals present, but generally they're metals, so they lose them. The problem is that some have one, some have two, some have one, some have two. That's the piece that's not very predictable. They're the least reactive group of metals, so they're a lot more stable. Okay, they are found in the middle of the periodic table. When we get into naming them, you will find that middle metals need a middle name. I have to put a Roman numeral where there are multiple oxidation states. And if you look on your periodic table, group 1 has all just one oxidation state, 1. Group 2, 2. These guys, some of them have 2 and 3 oxidation states. And so they need a Roman numeral in their name, and I'll show you why when that time comes. When we learn how to name compounds, that's a ways from now into bonding. But we're going to just foreshadow. We need Roman numerals in their names. We say middle metals need middle names. All right, now we're all the way over to group 17. This is the halogen group. So you see the name in there, halogens. Group 17 is the halogens. The physical properties, I have 7 valence electrons. There's all nonmetals in this group. There are 3 states of matter in this group. This is the only group that has that. I think that's a question on the test or the castle. It's on one of the two. So 3 states of matter found in here. There are solids, liquids, and gases. So the top 2 are gases. I believe iodine is the liquid, and then the rest are solids. No, bromine. My bad. Bromine is the liquid. Correction, Milks. Bromine's the liquid. And then iodine is a solid. Iodine to clean cuts, and it's a liquid, so don't get confused. That isn't actually pure iodine. That is tincture of iodine. It is dissolved. Okay. Hey, these guys are reactive too, though. Okay, they like to gain 1 electron and become a -1 charge. They form salts and compounds called halides, and they are also very reactive. Fluorine is in here. That's going to be on your note. Fluorine is the most reactive of the nonmetals because they only want 1. So it contains the most reactive nonmetal, which is fluorine. And the fluorine's the top one. So notice the top nonmetal that's a not noble gas, which is this side for you guys, is fluorine. And then on the bottom left is the most reactive metal, francium. Okay? Okay, here we go. Moving on. 7 diatomic gases. I know we've talked about this. These are special elements that exist as 2 atoms. Here in this picture is the 7 of them, and they show you them. Notice the colors or the shading. The colors in my picture, the shading on your black and white paper are all very similar. Okay, and there's 2 ways to remember them. Hofbrinkel, and there's one I haven't taught you, and that's the 7H club. And if you look at the diagram here in purple, you notice if I start at element 7, which is nitrogen, I actually make it, well, for you this way, I make a 7. That's the number 7 in purple, and then the H, so it's the 7H club. Okay, 7 plus H. Hydrogen is not a metal. Okay. Okay, names and properties of noble gases. This is group 18, and nobles are unreactive. The kings and queens don't hang out with us peasants, I like to say. These have full octets, that should say. They have their octet, which is 8 electrons in their valence shell, and they are all gases. They're called the noble gases. It's in their name, and they do not react with anything. So these are very unreactive. The science word for unreactive is inert. I believe that comes up in the POGIL. Okay, inert means unreactive, and don't tell me you don't care just because that's what's on the sign. I thought that was just a funny GIF for something you guys are all very familiar with, which is neon signs. Okay. What you don't know is that not all the gases and neon signs are neon, because neon has a specific color. If you want to change the color, you need a different gas. Ha! So there. This is a very stable group. They do exist alone in nature. They do not double up. They do not react with anything or anybody because they have a full valence shell. So their reactivity is based on their valence electrons, and they is full. Okay. They ain't giving anything up. The only exception in notes column for the octet rule is hydrogen. I'm sorry, helium, He. It only has two, but it's full at two. Okay. Everybody wants to be a noble gas and have 8 valence electrons. 8 is great. This is foreshadowing into bonding and why we bond. We want 8 valence electrons, which is stable. Okay. Good. Here we go. Two more: lanthanide, acidanide, and we'll talk about hydrogen real quick because hydrogen is not a metal, which we found out on our reference table quizzes. So our physical properties, they vary. They conduct electricity. They are metals, so we have all the metals, but they're very valence electrons vary. Their chemical properties, when exposed with air, they tend to have react with oxygen to form this oxide coating that tarnishes their surface. Okay. And some of their notes, 2 rows in the bottom table are detached. They actually belong to the transition metals. That's the notes for both lanthanide and acidanide. There's one thing that's fun about acidanide, 2 elements in there that are special. One of them is the boogeyman. So here we go. Acidanide is at the bottom column. Okay, again, valence electrons vary. This is all the same as before. Chemical properties. And notice I took luster off of there because they react. All of the acidinides are what we call radioactive. And they have several crystalline phases. Okay. And they're paramagnetic. Special notes. I'm guessing that this is the bottom 2 rows, or the bottom row. This is specifically 90 through there, and they actually belong in the transition elements, and some of them are radioactive. That would be plutonium and uranium. We've heard of those. Plutonium is in the bombs. Hydrogen has its own special group. Notice it's detached on our periodic table. It's non-toxic, non-metallic, odorless, tasteless, colorless, and guess what? It goes boom. It is highly combustible. I should have a GIF of the Hindenburg blimp going up in flames that was filled with hydrogen, which was a super light gas. Although it is classified as a non-metal, sometimes it does act like a metal. Notice it has 2 oxidation states, but we never call it a metal because it is a gas. Okay. Remember, metals lose electrons, so it can act like a metal, but it isn't always, and it doesn't happen very often. Okay. It's just a special disclaimer there. Okay. And states of matter, and I think then we're done, right? So there are 2 liquids on the periodic table. You need to memorize them. That's mercury and bromine. That's it. There are not many gases. I'm going to list them. Ready? And you need to know them and figure it out. There's places where you're going to have to draw them. So that's fine. So hydrogen, helium, nitrogen, oxygen, fluorine. A lot of these are diatomics outside of helium, and then the noble gases. So these are the 7 diatomics plus the noble gases, basically. Okay? And then guess what? Everything else is solid. So everything else. So we figure out which ones are liquids and then which ones are gases. Everybody else is solid. Most of those solids are metals. And I hope we are done. So sorry that was long. There's a lot of information to get through there. And good luck on your practice. Make me proud. Press the button and I turn off the video.